period of vibration T, the period of vibration T of a liquid drop depends on the density, the radius, and what? The surface tension of the liquid. Using dimensional analysis to deduce an expression for what? The dependence of the period of vibration of the liquid drop on these quantities. So they say we should deduce what? A relationship for what? The period of vibration using all those quantities, which is the density, the radius, and what? The surface tension. So therefore, let's write this down, combining all the of course the parameters. We have that the period T is dependent on what? Radius, of course, density, and what? Surface tension. So if we do that, introduce a constant, we have K, T is equal to what? We have T is equal to what? K, radius, density, and what? Surface tension. So let's call this equation 1. Therefore, we know that radius is L, we know density, of course, and we have surface tension. More of like a Y, of course, surface tension. Surface tension is so now surface tension is T negative 2. So let us first of all, we're going to assign, let's assign this is X, density Y, and surface tension Z. So let's call this equation 2. Then the first step, of course, is to what? Break this down in terms of what? A fundamental unit. Doing that, this becomes M0, this becomes L0, T1 is equals to what? K, Lx, of course, let's open a bracket right away. Some of you should understand this by now. So now the next step is what? Comparing what? Let's take like terms first. So taking like terms, we have K, M, so we have M, Y plus Z, L, X, negative what? 3Y, T, negative 2. So this is M0, M0, T1. So the next test, let's consider for Y. So for Y, we have, for M, sorry, for M, we have M0 is equals to what? My plus Z. So therefore, we can say that 0 is equals to Y plus Z. In turn, this is equals to what? Y is equals to negative Z. So take note of this. Take note of this. We have a first case. For L, we have of course, considering M, we have L0 is equals to what? Lx negative 3y, Lx negative 3y. So considering this, we have that 0 is equals to what? X negative 3y. So therefore, we see that x is equals to what? 3y. Very simple relationship. We have t. So for t, we have t raised to power 1 is equals to what? T raised to power negative 2. Sorry, negative 2 and negative z. This is negative z, not negative 2. So the concept is easy. Okay, wait. Take note. This is negative 2z. So please, very important to take note. Negative 2z, negative 2. This is negative 2z. So therefore, considering t, this becomes negative 2z. Very important. So this, we cancel this, of course. We have that 1 is equal to what? Negative 2z. So therefore, z will be equals to what? Negative 1 over 2. Z is equals to negative 1 over 2. So therefore, we have that x is equals to what? We have that x is equals to 3y. Z is equals to what? Negative z. So therefore, if z is equals to negative 1 over 2, therefore y will be equals to what? Negative 1 over 2. So y becomes what? 1 over 2. Then we know that x is equal to 3y. So if y is 1 over 2, x will be equal to what? 3 over 2, knowing that x is 3y. So therefore, x becomes what? 3 over 2. Y becomes, of course, y is 1 over 2. And z is what? Negative 1 over 2. So substituting this value into this equation, k, of course, we have that the period of vibration, t, is equal to what? K. We said x is what? X is 3 over 2. So we have arrow. So we have 3 over 2. Then we have the density, which is in y, which is y 1 over 2. And we have what? Surface tension is equal to what? Sorry, surface tension, which is z negative 1 over 2. So therefore, bringing this, we have that the tension is equal to what? K. Of course, all these parameters are what? In terms of 1 over 2, but some are negative, which is they will come down. Therefore, this will come down. Surface tension 1 over 2. So therefore, since all these parameters are in terms of what? 1 over 2, we're going to take it out. So we have K. So we have brackets, root cube, of course, density, surface tension, all over what? 1 over 2. And 1 over 2 means square root of what we have there. So we have the 10. The period of vibration is equal to what? K, the square root of what? Arrow, raised to power 3, density, and what? Surface tension. So therefore, this is the relationship, and this is what we have established when what? The period of vibration is dependent on what? Radius, density, and what? Surface tension.